Welcome to chapter 5. This chapter is going to be all about polygons, and basically those are just different shapes that we are going to look at. So we've learned a little bit about triangles already, but let's go ahead and review some information. Remember that with triangles, the sum of any two sides of a triangle must be greater than the third side. So if we look at the examples, basically you have to test 3 times to see if all 3 work. If one of them doesn't work, then you don't need to keep going because that means the rest of them aren't going to work. So for example, if we take 12 plus 6, is that greater than 5? Yes. If we take 6 plus 5, is that greater than 12? And the answer would be no. So this could not be a triangle. Okay? So let's take a look at the next example. So 7 plus 11, is that greater than 16? Yes. 7 plus 16, is that greater than 11? Yes. And then we have to do one more. We have to do 11 plus 16, is that greater than 7? And the answer is yes. So example B would be a triangle. Now the next example we've actually done on previous lessons before, and remember that when you're trying to find the restrictions on x, you take the 2 sides that were given to you and you subtract them and you add them. So if you subtract them, you get 5, and if you add them, you get 23. So if we were looking for a missing side of x, it would have to be greater than 5 but less than 23 in order for you to be able to add to any 2 sides together and be larger than the third side. So here we subtracted them, and here we added them. All right, the next thing we're going to talk about is the relationship between angles and sides of a triangle. And again, this is something we've already done before. So remember that the longest side is across from the largest angle, and the smallest side is across from the smallest angle. So let's mark these, and you can label them how you want. I'm going to put that 1 is going to be the smallest and 3 is going to be the largest. Okay, so then 3 would be across from the largest angle, 1 would be across from the smallest, and then 2 would be the one that's left over. And then let's also label the angles. So this would be 3, 1, and then 2. Okay? Okay, so let's take a look at the next example, ABC. Okay? And basically what the problem's asking is that if A is greater than B, then what can we conclude about the sides? So A is greater than B. So then that means that this side would be greater than the side across. So if angle A is greater than angle B, then that means the side across from A is greater than the side across from B. So we can conclude that BC is greater than AC. All right, next example. If C is less than B, so then that means across from B is going to be the largest, and across from C is going to be the smallest. So we can conclude that AB is smaller than AC. Okay. All right, now what if side BC is greater than side AB? So side BC is greater than side AB, smaller. Then that means that the angle opposite the smallest side is going to be less than the angle opposite the largest side. Okay. All right, let's keep going. So if AC is less than, so smaller, BC is greater, then that means angle A because that's going to be across from the largest side, is going to be greater than angle B. And you also could have written angle B is greater than, or excuse me, angle B is less than angle A, and that would have been true as well. Okay, and then last example, AC, so greater, is larger than AB, so smaller. So that means the angle across from the greater side, which is angle B, is greater than the angle across from the smaller side, which is angle C. Again, you can flip the order of this as long as you write angle C is less than angle B. So the main thing is just make sure that the largest side is across from the largest angle, vice versa, and the smallest side is across from the smallest angle, and vice versa. Okay, one thing that we hopefully know by triangles is that the inside of the angles all add up to 180. Okay, so if you have, x, 2x, and 3x, all three of those angles add up to 80. Remember that there's three angles in a triangle. So it says the measures of the three angles of a triangle in a ratio 3, 4, 5. What is the measure of the largest angle? So remember that anytime you're given these ratio problems, you assign an x to each one of those numbers. So 3x, or any variable, 4x plus 5x. Notice that I have 1, 2, 3 angles. And we set that equal to 180 degrees. Okay. From there, we just solve this. So this is going to be 12x equals 180. So x equals 15. And then the directions is to find the largest angle. So 5x is going to produce the largest angle. So then 5 times 15 is going to be 75 degrees. Okay, and then you can also plug 5 back into these two to make sure that all three add up to 180. Okay, let's go ahead now and talk about interior and exterior angles. So interior angles are the ones that are on the inside of the triangle. So, x, 2x, and 3x, those are all on the inside of the triangle. The exterior triangles are on the outside, exterior angles, sorry. So if I extended this, this would be considered an outside angle, okay? Or I can make it basically it makes a little pinwheel. So this would be an angle, and then this would be an angle. Let's go ahead and label this a different letter so it just looks different. Let's do W and let's do Z. And notice how I made a pinwheel. I could go the other direction, just make sure that you keep a pinwheel. And I'm going to erase this one. I don't like the way that I drew that. It was not very neat. There we go. That looks a lot better. So there's something special about interior and exterior angles of a triangle. Let's draw this off to the side. Okay. I'm going to zoom in. And what's special about interior and exterior angles is that the two remote interior angles will add up to the exterior angle. Okay, so if we had, let's say, 50 and 30, let's do 50 and 90 degrees, then y would equal 140 degrees. So the important thing to note is that it's the two angles that are not touching the exterior angle you're trying to find. They're across from it. Okay, so again, it's the two that you are not touching the exterior angle that you are trying to find. Okay, last thing we need to talk about is the mid-segment theorem. And basically what that says, the mid-segment is a segment that is joining at the midpoints of either side. Okay, and it is a mid-segment is parallel to the third side, and its length is 1/2 the length of the third side. So this would be considered the third side. Okay, and then it's parallel to this third side, and then it's also 1/2 the length of the third side. So if this is x, then this is 1/2 x. Okay, so it says given DE is a midsegment, determine segment DE and the measure of angle A. Okay, so again, the midsegment is the one that's connecting at the midpoint of either side, and it's 1/2 of the third side. So DE would be 13/2. Okay? And then the problem also asks us to find the measure of angle A. Well, remember that these are parallel. Okay? So if those two lines are parallel, then same side interior angles have to add up to 180 degrees. So 140 plus 40 gives me 180. Now I can look at the big triangle and see that 65 plus 40 equals 105, and then subtract that from 180. And that gives me 75 degrees, which equals the measure of angle A. So biggest thing about the midsegment is that it connects at the midpoint of the two sides of the triangle. It is parallel to the third side of the triangle, and its length is 1/2 of the third side. Thanks so much for tuning in.